Okay, hello students. This is the video number 2 for motion, and I'm taking these three numericals for you so you can understand the acceleration topic very seriously. So let's start with the numerical. Number 1, a bus accelerates uniformly from 18 km per hour to 36 km per hour in 10 seconds, and I have to calculate the acceleration. We know the formula, that is A is equals to V minus U by T, that is final minus initial by T. So but in this question we have seen that this is kilometer per hour, this is kilometer per hour, and this is in seconds. So I have to convert these two. So you know that in kilometer per hour to meter per second, I have told you many times, multiply by 5 by 18. So it would be 5 meter per second, and 36 into 5 by 18, it will be 10. It would be 10 meter per second. This is 5, so this is final, this is initial, so it would be 10 minus 5 and divided by time, that is 10 second, that is 5 by 10, and you can say that 0.5 meter per second square. Easy. Second, a bus is moving with a speed of 18 km per hour. It comes to rest in 3 seconds on application of brake. Then find the retardation. In this question, he himself said that find the retardation. So we know that our answer will be negative because brakes are applying on the application of brakes. You can see that from here. So a bus is moving with the speed, that means it comes to rest. If a body comes to rest, that means it is not moving, so its final velocity would be 0. If body is at rest, its velocity is 0. And initial, it is given 18 km per hour. We will multiply by 5 by 18, so it would be 5 meter per second, and time is given to us as 3 seconds. So acceleration would be V minus U. Every time you write the formula, 0 minus 5 divided by 3, and it would be minus 5 by 3, and you can say that minus 1.66 meter per second square. So these are the simple question. One is of acceleration and one is of retardation. I have in previous video I have given you two numericals. So let's start with the third numerical, which is of your NCERT. So this question says that a train starting from a railway station and moving with a uniform accelerations attains a speeds of 40 km per hour in 10 minutes and find its acceleration. And this question also of retardation, but he have used the word acceleration. So you have to calculate the acceleration, but first of all just read the question once again. That it's moving with the uniform train from railway station. It start when in question it is given that body is from rest or it has start, so you have to take the initial velocity 0. That means we suppose that the body when it start, obviously velocity was 0, so our initial velocity in this case is 0. When body is at rest or if it has a start, just start, so u is 0 and attains a velocity of this. So this would be your final velocity, 40 km per hour, and your time is given, that is 10 minutes. They both are not in units, so you can say that you have to make them in units. So it would be if you multiply this 40, v is equals to 40 into 5 by 18, so it would be I think 100 by 9, and time is your 10 minutes. It would be 10 into 60, so it would be 600 seconds. So acceleration is v minus u by t, and it can be v is your 100 by 9, u is 0 and divided by 6. It would be 100 by 9 into 600, so it can be written like this. This is correct answer, but so many students say that this is very low acceleration. You can find in kilometer per hour, but it can be like this. For example, in same case u is 0, but I suggest you to do this method. Okay, this is good, but some teachers not prefer that 40 km per hour. If it is in kilometer per hour, I can change that time 10 minutes into hour, that would be 60. 10 by 60, that is 1 by 6 hour, from minute to hour. So acceleration same, v minus u by t, that is 40 minus 0 divided by 1 by 6, and this 6 would be go like this, and 40 into 6, that would be 240 kilometer per hour square. For like this, meter per second square would be kilometer per hour square. So make this thing. So try more numericals. I'll give you assignment on acceleration part, and I hope you will understand this thing. Thank you.